All right, let's get started. Hello and welcome everyone. Welcome to today's webinar, Reimagine and Reinvent, part of our ongoing innovation webinar spotlight series. My name is Tammy Pisani. I'm the membership manager for Queensland and I will be your host today. Before we begin, on behalf of Osmine and all of today's presenting companies, I'd like to acknowledge that I am hosting this webinar from the lands of the Turrbal and Yagara people, and that we acknowledge the traditional custodians of the various lands on which we all meet today, and recognize the Aboriginal and Torres Strait Islander people attending this webinar. The Innovation Spotlight Series provides our members a way to showcase their innovative solutions, techniques, and technologies, and to see what the next phase of mining holds. Today, we continue that series with Reimagine and Reinvent, showcasing our members' expertise in breathing new life into traditional mining products. This includes mineral exploration challenges, absolute gravimetry, strategic mine planning, and 3D metal printing solutions. Daniela, could you do the next slide for me, please? I am joined by 4 industry-leading member companies sharing their improved outcomes using technology, systems, and know-how in the mining supply chain. Joining us to share their expertise today, we have Clarissa Campos, Mining Marketing Manager with Fleet Space Technologies, Kyle Hardman, CEO, Nomad Atomics, Gustavo Pilger, Worldwide GEOVIA R&D Strategy and Management Director with Dassault Systèmes, and Ben Hockley, Head of Sales in Australasia for SPEE3D. The format of this webinar will include a short presentation from each of our presenters, followed by a Q&A session. If you have any questions during any of the presentations during the webinar, you can use the Zoom interface to type in, pardon me, your questions into the Q&A box at the bottom of your screen. And if your question is directed to a specific speaker, please note that in your question. This webinar is being recorded and will be shared with all attendees. All right, so that concludes the welcome and instructions. So without further ado, I would like to welcome our first presenter, Clarissa Campos, Mining Marketing Manager with Fleet Space Technologies. Clarissa, over to you.
Thank you so much, Tammy. Hi, everyone. Thank you for joining today. It's an honor to be here, and thank you, Osmine, for the invite. It's always great to present along with other industry experts about innovation and the future of mining. So today I'll be talking about how we are uniting industries to unlock discoveries in the energy transition. So I'll try to keep it simple and short as, we're not going to be delving into too much technicalities, but having worked out 12 years in mining, I think nowadays we have one of the biggest challenges as the industry is facing, which is the energy transition. And it means that we need to find new mines, not in 20 years' time, not in 30 years' time, but like we need to find them right now. And that's how we are trying to solve this issue by uniting so many different industries and aspects of innovation. So if we look at the numbers for mineral exploration today, we have 80% fewer copper discoveries worldwide in the last few decades. Those discoveries are also getting deeper because most of the shallow deposits have already been found. And not only that, the drilling success rate is really reducing dramatically to less than 1% of everything that we drill, we actually can find something. So there is, a lot of money, a lot of time, a lot of energy invested in that. And we think there's a better way to do that. So I work with geologists and geoscientists every day, and I know how excited they are to go on a field trip and to find, new rocks and make the next big discoveries. But the reality is it's pretty hard. And when they get back, home, usually the outcomes are quite different, and companies have spent a lot of money, a lot of time, and a lot of energy trying to find the new resources, and the numbers are not just showing up. And Basically, in order to really meet the needs of the energy transition, we need to accelerate mineral discoveries by 10 times, which means that we need 17 more Escondida mines or 600 more Cadia mines, which is insane that we are able to do that in such a short period. So that's why we are on this mission to try to really accelerate that pathway and really bridge that gap of supply and demand for the energy transition. And how can we do that? Well, first of all, we thought, well, we can add a new technique and that will help us address the problem, but only a new technique. It's not going to be enough for us to solve the whole puzzle. So what if we also add artificial intelligence and the space capability? So by adding those three things, we are actually thinking that we are, giving several steps to really accelerate and make the next big discoveries to meet the energy transition. So just quickly about the first pillar. So we started using this new technique called ambient noise tomography. It's a new technique in mining, but not in other industries. It has been around for several decades, but now we have been consistently applying that to mineral exploration. And basically, we are listening to the Earth's noise. There is an ambient sound ever present in the Earth, and we are able to correlate that with different rock properties. And we are able to generate 3D models of the subsurface by doing that. So that's the first pillar that we actually use. And the other one is the artificial intelligence. We know that a lot of companies have a lot of data, but how can they rank better targets? How can they really make better choices and decision making by knowing which prospects are better than others so that they don't spend millions of dollars drilling things that are actually not there? So by training this model with AI and correlating with our own data sets, we actually have way better chances of, guiding our clients to the best areas and the best outcomes that they can have. And the last component is space. So how can space really help us? Well, space is an enabler because it adds a lot of speed to the whole process. And for the ones of you who are in mineral exploration, you know how the process is very lengthy, it's very expensive, and things take usually a lot of time, sometimes can take months to have, survey results, and sometimes the results are not good, so you have to start from scratch. And by having the satellite connectivity and the space component, it means that you can access the results in real time. You can know straight away if the areas are good or not, and if they're not good, you can repurpose them to a different area so that you can make the most of the surveys and don't have to wait a whole season to find out how they are turning out. So by uniting those three things, we created and launched Exosphere a few years ago. And Exosphere basically is generating the 3D models, data sets of the subsurface. We can map up to 2.5 kilometers down. It's all connected to the satellite, so everything is digital. You have all the data straight away. And the best thing is it has almost zero environmental impact. And that's one of my favorite things, because having worked with technology, sometimes you have great products and techniques, but if they're, polluting, or if they are not doing things in a sustainable way, it's quite hard to be scalable. And in our case, because we're listening to this sound that is ever present in the earth, we don't need to generate, noise. We don't need dynamites. We don't need vibration trucks. We don't need any of that. Basically, we place the sensors on the ground. They start listening to that noise, and then you're able to really leave them there for a few days and then move to the next areas of interest, and really having an amazing ESG practice for mineral exploration. And the other aspect too is that you can have the survey dashboard for real-time quality control. So it means that you will know where the sensors are placed, their battery levels, and when they reached, most of the data, so that it's time for you to change the location and move to the next area of interest. So you know straight away, and in case if there are any issues, you know how to fix it. And in the other methods, you can't really do that because you don't have that satellite component. And the models, as I said, they are in 3D, so that adds the depth aspect. And that's very critical to make a big discovery, because sometimes you are in the right zone, but you're not going deep enough, so that depth aspect is really key to solving that challenge. So basically, we are providing an end-to-end solution that provides a lot of speed. It's scalable. You can use in any tenements, and it's enriched with AI. And you're basically constraining the data from the field. You are getting closer to the targets that you're looking for, and you're also discarding areas that are not looking so good, so that you can also save, money on drilling, and you don't need to generate that environmental impact in areas that maybe, the probability of finding something is really, really low. So you can use your budget more effectively as well. So those are the key things and innovations that we are working with. And yeah, we have been doing that for several years now, and we're really happy to see how we can combine different industries to really solve that big challenge that we are all facing in the mining world and in the energy transition. Thank you.
Fantastic. Thank you so much, Clarissa. I can really see how using real-time data is going to be a huge advantage for exploration companies. All right, next I would like to welcome our next speaker, who is Kyle Hardman, CEO of Nomad Atomics. I'm just going to hand it over to you, Kyle. Thank you.
Great, thank you. Let's get this going. Yeah, look, hello everyone. Like she said, I'm Kyle Hardman, and so I'm one of the founders of Nomad Atomics. And first of all, I'd just like to thank the whole team at OSMine for giving me the opportunity to share Nomad, to share our technology, and of course, to share our vision of how we see this technology enabling explorers and producers of today, and as well as well into the future. So today, I'm here to talk to you all about this. So I hope everyone is ready for a quick physics lesson, but don't worry, we're not actually going to go through all of this, but the question is, what is it, right? Well, this slide here really outlines with some nice figures and math how a technique called atom interferometry is used to make measurements of gravity. And a keen eye would have picked this up straight away, given that gravity is written in giant blue letters there, and there is a suspicious number of G's in all of these equations. So, why is this important? Why am I showing you this? Well, I'm probably showing you this because gravity has been used as a critical tool in the resource sector for really the last 40 to 60 years. But for some reason, we are still using the exact same technology that was developed 40 and 60 years ago, right? All the ground and all the airborne based gravs still rely on old measurement systems using mass and springs. They're really susceptible to vibrations and shocks. They have biases, they have scale factor errors, offsets, they require calibrations. They're just really not ideal tools to use in this space. And then we can look even further to a little bit more technical things where we have ground-based absolute sensors such as the A10s, but they're very large, they're power hungry, and I would say that really they're so big that they can't be used for really any useful measurements at any scale useful for exploration or monitoring at all. And then everyone's favorite, at least in the petrophysics world, is the airborne gravity gradiometer systems, right, which were developed about 40 years ago. And like, don't get me wrong, they give us amazing data outputs, but they're large. They have to be flown on, helicopters or aircraft, and they're prohibitively expensive for anyone outside of the majors to actually run. So where do we fit in? Well, so we at Nomad focus on the development and deployment of quantum gravimeters and accelerometers, effectively all that math that I showed you earlier. Our technical teams have the expertise in these fields, and we've been responsible for developing systems all over the world. Each of us individually have been, right? So we have developed the first quantum gravimeters in Australia. We deployed the highest accuracy gravimeter flat out through deployments across Europe. And we even essentially drove Australia's first program integrating the same technology down for defense navigation purposes. So we've been in this world for a really long time, and we're trying to push this into this resource world. We've kind of taken all that expertise that we have, right? And we've focused really heavily on our full stack hardware development, right? We build unique built for purpose tools designed from day one, right, to meet the capability and swap requirements needed specifically for the resource sector. It's important to note that we are an integrated or vertically integrated company, right? So we don't just like Clarissa was saying about Fleet, right? We don't just build, that underlying hardware. We actually get out into the field. We provide that data acquisition service. We build those gravity maps. We do the analytics and any inversions that we need to for any dynamic underground systems that our sensors are used on. Now, I think this is really critical, and Clarissa said this a little bit as well, right? It's important that you have this understanding of that entire value chain here, right? It allows you to, really dig deep into the future and the current applications of all this technology, and really to build the systems that are deployed in the ways that they need to be to solve the problems that you're facing now, and even open all these other applications for technology or say seismic, like Clarissa was talking about. So what have we been doing? So over the past couple of years, we've been developing this system here called Absolute G, for those of you that know your math symbols. So G is a self-contained and survey style absolute quantum gravimeter, right? So the sensor is fully self-contained. It's a volume 23 by 23 by 30, has a mass of about 15 kilograms. And it contains everything in this one sensor head. So we use cold atoms, so that atom interferometer system that includes all of our lasers, our control electronics, the batteries and the powers. Everything's kind of in that one box. We designed this sensor for anyone that knows these dimensions, specifically to have a similar kind of operational mode and size as the old Syntrec CG system. So think CG5 kind of thing. And we did that because we don't need to use the CGs anymore. We don't need to use relative gravimeters anymore, right? So we want to just kind of put this into the world and displace this old way of doing gravity and give you access to data and data quality that you didn't have before. So this device here addresses those critical problems with those land-based gravimeters, as well as some of the airborne systems of data quality and drift and tarring and bias and all of those things. So systems like G, of course, offer a number of advantages for exploration, mapping, monitoring systems, right? Which are really, really important when we're looking for those resources of the future, or we're trying to make sure that the resources that we have are mined, efficiently. So they're robust, they have no moving parts, they don't rely on any mechanical properties at all to measurement systems. They have a serious pathway for miniaturization. This is just step one in this picture here, right? They're accurate, right? Which means that they don't need to be calibrated. You don't need to do repeat readings, no tie points, none of that. And because they're accurate, they have no drift, right? They are inherently bias free. That gives you the ability to do real-time time-lapse gravity, right? Where you can go back to site one time after another, month apart to years apart, and actually watch the development of the mass in that system. Think maybe underground systems, water influx, that kind of stuff. So I said this a little bit, but I think this is really important, right? Systems like G really operate, and they're only useful because they have a very, very specific set of characteristics. And I think there are three that are very, very important in this world. There's low size and weight, right? And this in particular, these quantum gravimeters and us in particular have this, they have a real pathway to miniaturization. And think the systems that we're building now and working towards in the future, you can think like Coke can size gravimeter, absolute gravimeters, right? They have high sensitivity, so they can detect really, really small changes in your environment, and they have high accuracy, right? Which means that you have data certainty. You're always certain that your data is accurate, at least coming from the sensor, right? And when you have all of these characteristics combined into a single sensor, you kind of start to unlock all the real advantages and this really, really unique, I would say, long-term tech pathway that leads to new capabilities, right, and new applications across the resource exploration and production markets. And so, yeah, so like I said, we're here on this left side of this graph here now, right? We have an absolute gravimeter. We can do, these really cost-effective, large-scale absolute gravity networks. Think, regional scale. Think continent scale. When you have a device like this, that you can just fly around anywhere and plop down. We can have really, really high fidelity land exploration, right? We can also do time-lapse gravity of underground systems. So anything underground where your mass is moving around, underground mines, water influx of surface mines, anything like that. Like, we can do these things now with gravity, right? And these gravimeters that we're producing. We're currently working to make these all autonomous, right? To essentially remove that personnel overhead from these systems so that you can have that really efficient exploration, drive the cost down so that anyone can afford to do really large scale gravity surveys with really, really high precision. And of course, we continue to move in that direction, right? As you make things smaller, make things more deployable, make things more autonomous, you start moving towards those airborne systems, airborne gravity, and yeah, things like that. And of course, just to kind of wrap things up real quick, right? What can we do with all this? Well, if you break it down into the two kind of worlds, we have exploration and monitoring, right? And I went through this a little bit, but the things that are really, really important here are that we can do really cost-effective absolute gravity networking today, right? By implementing these sensors. We can build autonomous systems. We can drive the cost down of exploration and really, really long, really, really large scale exploration practices, which is really, really important. And I think for me, the thing I'm most interested in is this idea of monitoring. It's the idea that you can use gravimeters to do very, very long-term monitoring of underground systems. And it's really the only technique out there that gives you some really, really neat characteristics, right? It's completely unshieldable. You don't have like gravity noise flying around in the world all the time like you do with magnetics or EM. You can, yeah, I mean, yeah, that's probably a really big one, right? And the other really interesting thing is you can do direct measurements of mass, right? So if the mass moves under the ground, or 1,000 kilo mass moves under the ground, I can tell you that that mass was 1,000 kilograms. It was moving around. And this can be applied to all sorts of unique things like void detection, monitoring of underground mines, as well as water influx monitoring. So yeah, I understand that this slide is very, very thin on details, And there's a reason for that, but feel free to reach out to me if you want to talk really details about any of these applications, especially if you have an underground mine. I'd love to talk to you. And I think.
All right, awesome. Thank you, Kyle. Perfect. Thanks. The application of these durable and accurate sensors seems endless in mining. So fascinating stuff. Thanks for sharing that today. All right, now let's move on to our next speaker. I am pleased to introduce everyone to Gustavo Pilger, who is the Worldwide GEOVIA R&D Strategy and Management Director at Dassault Systèmes. All right, Gustavo, over to you.
Well, thank you. Hello, everyone. Thank you, Tammy. And thanks, Ostmind, for the opportunity to present at this forum. So today I'm talking about the benefits and the power of integrating the processes of mine planning and design. The traditional mine planning process is often subject to disconnected systems, isolated data, and limited scenario analysis. This often leads to suboptimal decisions and, more importantly, to missed opportunities. From a general standpoint, mining engineers are faced with the challenge of optimizing a mine plan, sometimes including a few pits and various destinations, also considering a multitude of constraints and modifying factors. So, because of the complexity of the optimization problem, it's often difficult to assess multiple scenarios or hypotheses within a reasonable time frame. And also the end result is not guaranteed to be operationally practicable in terms of pushbacks and design, leading to rework and deviation from the optimal target. So the Dassault Systèmes business platform, the 3D experience, provides the necessary building blocks to integrate these processes in a meaningful manner, facilitating that the space of possibilities are assessed while ensuring that mine plans are optimal, robust, and practicable. So from the top going clockwise, the data is stored in a single repository and described in a way that is seamlessly understood by adjacent processes and algorithms through dedicated data models, leveraging ontologies and a semantic dictionary. It counts with sophisticated algorithms for solving complex optimization problems within reasonable timeframes. And also it allows assessing multiple possible scenarios. It's meaningfully connected with our generative design processes in a way that changes in the mine plan propagate to mine design so that designs are parametrically adjusted to reflect mine planning changes. And finally, the data and project is centrally managed, providing full control and visibility of the life cycle of data and projects. But what is the 3D Experience platform? Simply put, it is a science-based platform that hosts a range of apps that enable engineers and professionals overall from different industries to realize their tasks, their jobs, in an efficient and scientifically accurate manner, from a multi-physics and multi-scale standpoint. In terms of integrated mine planning and design, I would like to call out a few key innovations here. So first, unified data management in 3D Experience, which is deployable on cloud or on premises, enhances team collaborations and process transparency. Second, we have a new powerful optimization algorithm, which combined with cutting-edge techniques is delivering improved NPV faster than the benchmark. We provide direct associativity between mine planning and parametric design, ensuring seamless synchronization for more realistic schedules. And we also allow to optimize mine plans considering sustainability KPIs, such as emissions, energy, and water usage, ensuring that environmental stewardship is embedded into the optimization process. So here's a quick demonstration of what our solution can offer. This video highlights a few key features, such as the integrated nature of 3D experience, centralizing data, decisions, and management overall, promoting visibility and transparency to all stakeholders, while providing seamlessly connectivity between mine planning and design. It fosters collaboration through centralized and streamlined workflows for managing the life cycle of data and projects overall, enabling informed, data-driven decision-making. It counts with powerful optimization algorithms capable of solving complex optimization scenarios to uncover robust mine plans, balancing economic, environmental, and safety considerations. And finally, it provides visual capabilities and sophisticated analytics for extracting deep insights of the data, enabling mine planners to unfold the results for investigating further opportunities for improvement. And here is another video that illustrates the integration of mine planning and design. So from the optimized pit and phases, one can then specify geotechnical constraints, establish bench parameters, to then parametrically create multiple phase designs. The mine engineer then can create the ramps in a parametric manner, and after that, the engineer can easily modify and regenerate the design as required. In a similar way, the engineer can design dump piles and generate volume and tonnage reports. So in summary, the Dassault Systèmes integrated mine planning and design capabilities on the 3D experience introduces a transformative shift in the industry. By unifying design, operations, and sustainability, mining companies can now take more informed, data-driven decisions that maximize value while prioritizing safety and environmental responsibility. Again, we provide a unified, integrated solution capable of solving complex mine optimization scenarios faster than the benchmark, with the ability to assess multiple scenarios within a collaborative framework. And the end result's not only optimal, but it is operationally practicable in terms of pushbacks and design, maximizing value and minimizing rework. And thanks for your attention today.
Thanks so much, Gustavo. Great to see a software that breaks down all of the data silos associated with mine planning and design. Thank you for sharing that with us today. All right, now we're going to move on to our final speaker. But before we do, let me remind everyone that you can submit your questions for today's speakers in the Q&A box in the Zoom at the bottom of your screen. So please submit your questions. All right, so finally, let me introduce you to Ben Hockley, Head of Sales Australasia with SPEE3D. All right, Ben, the floor is yours.
Thank you, Tammy, and thank you to Osmine for the opportunity to talk about our technology. So yes, I work for SPEE3D. It's an Australian company that developed a new method of metal printing. And the background is that our two co-founders have a manufacturing background, and they were frustrated essentially by the casting process, the long lead times around casting. And then on the flip side, the existing 3D metal printing processes were just also too slow and quite expensive. So they were looking for a much faster way to manufacture metal parts. And they noticed that there was this method of laying down metal powders using cold spray. It had been used for quite a long time just for coatings in different industries, but they set about controlling the deposition of those coatings to make 3D metal shapes in very fast and at a very low cost. So this image you can see here is one of our first printers that we developed, and it's a great way to explain how the technology works. So essentially, inside that printer, there is a build chamber, and you can see a picture next to the one section of our rocket nozzle pointing straight up from the bottom of the build chamber. And we use compressed air to pick up metal powders, and we can work with a range of metal powders, things like aluminium, copper, bronze, stainless steel, and we've got a lot of other metals in the works as well. And essentially we use compressed air to push that metal powder up through that rocket nozzle. And when it comes out of there, it's traveling at 3 times the speed of sound. And when powders collide with something at that speed, they basically deform and bond. So what we need now is to be able to control where we're depositing that metal powder. And we do that with the robot arm. You can see that next to the number 2. And we control that robot using our patented twin speed software. And this is the real IP of our company, is we've got patented algorithms that can control how that robot moves to deposit the metal powder in just the right place to make the 3D shape. So you can essentially import a CAD file of a part that you need replaced, and our software will write a toolpath to control the deposition of the powder to make 3D shapes. It's best to visualize it by seeing it here. So you can see we're shooting the powder up, and we've basically imported a CAD file of a human hand that we found, and our software wrote the toolpath for the robot to deposit the metal powder, and it does it at an incredible rate of up to 6 kilograms per hour. And our build chamber is about 1 meter by about 700 high, so we can make very large, very dense parts. Now, once these parts come off the printer, like I said, they're almost at 98% density, but they are brittle, so we would then put it through a heat treatment, and that will get mechanical properties that are better than cast. So we can make very strong, durable, large parts very, very fast. And the big advantage is, compared to a casting process that literally could take weeks or months, you can see here there's a workflow to make a 6 kilogram bronze part. And you can see it in the morning. It takes a few minutes there for the software to process the toolpath, and then it only takes an hour to print 6 kilograms of bronze. And then we would put it into a 240-minute heat treatment. Followed that, so we do get to a near net shape. So it's not a very high resolution process. It's a near net shape. So we get about 1 mil tolerance from the final geometry. So then we would use a CNC mill to get those final geometries, and then perhaps half an hour to test the hardness, make sure the part was met the criteria. So you can see here in an 8-hour shift, we've actually made a bronze part that can be deployed, like it could be a door latch on a truck, or it could be anything. So so this is the real advantage, is the speed to make replacement parts in the field, because the printer you saw, all it needs is an air compressor, a dust extractor, and a powder hopper. So the Australian Army actually saw the possibilities of this, and they actually asked us to do field trials with them. So we took the whole system out to their exercise grounds in the Northern Territory, and we demonstrated to them that yes, we could replace broken metal parts from vehicles, equipment, machinery. We could do that in the field, and we could get their equipment and operating again. So this is why I'm here today, is because it's all about working in the war against downtime. And obviously for the Army, that's very expensive, but also for the mining industry, it's incredibly expensive to be waiting for parts to be coming from the other side of the country or the other side of the world, potentially. So this is a method of being able to make metal parts in very remote, austere locations. But the feedback from the Australian Army was it's quite a large footprint. You can see there we've got all the different pieces of the solution under the canvas. So they asked us if we could make it smaller and more mobile. So that's when we developed our latest version of the printer we call the X-Speed, and it's essentially now just 2 shipping containers. So inside these 2 shipping containers, the first one is the printer. So that's got everything you need to make to do the printing. You've got your the printer itself, you've got the air compressor, the dust extractor, the powder hopper, all encapsulated in that one 20-foot shipping container that can be loaded on the back of a truck and delivered just like any other container. The second container is what we call our cell, or our post-processing unit. And in there, we actually do have the ovens for the heat treatments. So we can, there's 2 different kinds there. So we can actually heat treat multiple different types of metal. And then there's a milling machine there to get those final geometries, and then a testing station. So with power and these two 20-foot containers, you can stand up a metal manufacturing facility anywhere on the planet, essentially. So we've demonstrated that to the defense organizations around the world. You can see here the US Navy asked us to prove that we could do this kind of printing at sea, which we've done. We also have 10 printers in the battle space of Ukraine. So we're helping to them to keep equipment that they've had come from all different parts of the world. So the supply chain to support those pieces of equipment is very problematic. So now they can actually manufacture some of those parts that they need near the battlefront. The Japanese Army have also acquired the technology recently. We've also tested it in, we already did Northern Territory, so we know it works in the high heat and humidity, but we recently did a testing exercise in Alaska, so we know that the technology works in the very cold. So we're pretty much confident that it can work anywhere on the planet to support mining operations. Also, we've been working with the US Submarine Subsafe Corporation, helping them to, because there's some really great opportunities, because this is a new method of manufacturing metal. And so you have quite a lot of control and different parameters that you can apply. So they've been funding research on particular metals that they need for their submarine program. And in fact, next week, we're launching these material systems to the public as well. So that's another material that we'll have very shortly. So here's some examples of the applications, the type of parts that we can make. We've actually made parts that have been fitted onto every one of these pieces of equipment. And I'll give you some examples here. There's a cam lock fitting that was kept corroding on the patrol boat. And so we could actually print that cam lock fitting in 24 minutes, and then we would put it through the heat treatment, and then they would just machine those final geometries there on the end. The top of it is left as printed, but we just smoothed up the where it mates with the hose. So that's and then we've got a bilge pump housing that we made for an Army landing craft that took a bit over an hour and a half, plus the heat treatment. And so here we can make tools that only took 9 minutes to print, plus the processing. The exhaust on the M113, they keep knocking that off when they go under trees. So we made a replacement part that was actually stronger and more durable than the original. And we did that in the field. You've got some more tools here in about half an hour. We've printed a sprocket wheel for a tank. So we replace that in the field and operates in a couple of hours. A bow shackle to get a large vehicle out of the mud. That was 2.5 hours. We've got a towing eye there. So that's a big part. That took 5 hours to print that. And you can see that on the front of the tank there. So yeah, we've also, as I said earlier, there's some great opportunities around materials development. So if there's any particular materials that you're needing in the mining industry, reach out. We'd love to hear about the challenges there. But also, we'd be keen to talk to anybody about deploying this technology to support mining operations. Thanks for listening.
Thanks so much, Ben. Thanks for sharing that new technology that is definitely meeting today's on-demand requirements. It's really fascinating stuff. All right, well, now it is time for the Q&A. So please feel free to submit your questions. I do have a few here. Let me just start off by asking Clarissa, this one is for you. How is the mineral exploration journey changing throughout the years?
Yeah, that's an interesting question. So I think there's a lot of things going on in that space. Traditionally, if we look at how the geophysical and mineral exploration surveys were done, they were obviously taking too long. The data quality was not good. As I quickly mentioned, sometimes you would spend 6 months or even more to receive the data to find out that they were not good and start the process all again, redo the survey, send more people to remote areas, and that it's really inefficient. And the other aspect is now that with AI, with other technologies and also how other industries are being incorporated into mining, that really leaves a space to, you know, digitalize a lot of those processes, shorten the periods, the chain, add more value, and also have more data integrity to really make the decisions that are critical for any mineral exploration project. So I think it goes through people, through technology, but also through a lot of the changes that we are seeing, you know, to meet the challenges that we are facing nowadays.
Yeah, great. Thank you. Ben, I have one for you. What if you don't have a CAD file for the part that you want printed?
Yeah, so you can use 3D scanners, a very convenient way of doing it. But we actually find that the nature of the type of parts we're printing, it's actually quicker sometimes just to literally get the calipers out and measure the part. And the CAD systems these days are a lot easier than they used to be to draw up 3D shapes. So yeah, it's very efficient now just to literally measure the part and draw it up in your CAD programming system, or use a 3D scanner. Yeah, either way.
Yeah, great. Thank you. Gustavo, this one is for you. What are some of the change management challenges for implementing an integrated system of this type?
Yeah, sure, Tom. So yeah, with implementing new systems, of course, change management is a common problem, not only for applying a new software, but for applying a new way of thinking. And this is no different. The challenge is, and the key is to take people on the journey, right? Explain why we are doing this, explain the benefits and where we are gonna want to get. Use the same language, the same terminology is really, really important. But taking people on the journey, showing and demonstrating benefits along the way is also really important to make change at the end of the day. And in these particular examples, we are experiencing and observing tangible improvements when it comes to NPV and performance overall. NPV improvement, we are observing of the order of 15 to 20%, depending on the use case. And performance is faster, way faster than the benchmark. I remember when I was a consultant, leaving stuff to run overnight. Now it's just a quick coffee break, and that's it. Coffee break.
Great, thank you. All right, Kyle, I've got one for you. What is the single greatest advantage of an absolute quantum gravimeter? And is there a disadvantage?
Best advantage, I would say it doesn't need calibration. I mean, I think the not needing calibration really changes how you do exploration. It also leads to a lot of really interesting things in monitoring, right? And actually monitoring active mines or anything like this. And it means that you can do really specific things that you would not have thought gravity could achieve. And again, I think I'm light on details in this, especially for the mining like production and monitoring things. And I'd love to talk to some people about that if they had questions in more detail. Is there a disadvantage? I would say it's a new technology, right? It's still new, right? These things are just now getting implemented out into the world. And so, of course, there will be hiccups, but I think the future is looking very, very good in the amount of progress that has happened over just in the last couple of years in this space. There's no reason to think these will not be something that dominates this field in the next couple of years.
Fantastic. All right, Clarissa, one more for you. How does the real-time capability in mineral exploration add value to the mining industry as a whole?
Yeah, the real-time capability is really a game changer, because it means that you are totally changing and disrupting the times and processes that the mineral exploration industry works with. So instead of working, with, months of wait, now you are talking about days. And when you shorten that cycle, it means that all the decisions are made earlier. And you make the decisions earlier, you're changing the whole chain and also improving, the way that things work throughout the mining cycle. So that is the real-time capability. So it's not having quick data for the sake of it. No, like if you're having the data and you're not deciding and you're not using it for something greater, then it has no value, right? But if you're using that to really fast track your whole process, saving a lot of time, people, resources for months, and really doing that earlier, then you're disrupting and changing everything that's coming after that. And everything starts with discoveries, right? If you don't have that, you don't have a mine, you don't have the supply chain, you don't have the whole things that needs to happen with that starting point. So that's the power of the acceleration of the technology and its impact.
Fantastic, thank you. Well, unfortunately, that is all the time we have for Q&A today. I would like to thank everyone who attended today's webinar. We look forward to welcoming you to another OSMINE webinar in the future. And finally, I would also like to give a big thank you to Clarissa, Kyle, Gustavo, and Ben for sharing their expertise in new technology with us today. And thank you for everyone who attended, and enjoy the rest of your day. We'll see you next time.